All right, Advent of Code, 2019, day one. I am solving this in Elm, and I made some wrapper code um, to execute Elm from JavaScript. So if we go here and do this, this builds our application. Does we want to run day one, part A, and we want to use our makefile as input. And pretty much all of the Advent of Code problems, at least that I've come across so far, are basically pure functions string to string. So here we're just as a test for passing in our makefile, and it's coming in here to solve for day 01A, and it's just using the identity function to just pass that string straight back. So that's how we'll execute it. We also have tests. Quick. There's our tests. And then over here is my output. So I'm going to be switching back and forth. This is my code terminal, and then this is the just watching the files for changes and then executing the tests when it sees them change. So right now these are just expecting basically the string 1, 2, 3 equal the string 1, 2, 3. All right. So problem number one. Let's go no go pull here. I'm just going to pause this while I look through it. All right, so coming through this, basically have this formula for finding the required fuel for a module, which is divide its mass by 3, round down, and subtract 2. And then we have these basically 4 test cases where for a mass of 12, we expect to get 2, 14, we expect to get 2. So I've taken all 4 of these and converted them into test cases, which are failing. And they're failing because we don't have a required for fuel on our A module. And so we can require fuel for mass. We can export that, define it, and it is going to take an integer and return an integer. So we're going to take in mass and divide by 3, round down, subtract 2. So round down, if I'm not mistaken, we can do with floor. So we're going to want to divide the mass by 3, which, yeah, I was going to say it's going to want a float from mass. So we can do that. No, it wants both as floats. And and then floor is what we're going to want here, which is in basics, I believe. And there we go. Okay, so now it's wrong. Also, the fixity here is such that these get evaluated first, but we don't have to tell it that. So we can first divide by 3, and then round down, and then just to keep a pipe here, we can subtract 2, and that gets us to what appears to be, oh, actually, did I miss a number there? Looks like I missed a number. 3, 3. Value in my tests. And now they're inverse of what they should be, which is interesting. That passes. I'm not sure why that's the case, but that passes all of the specs. So we'll leave it, and let's see if we can get, okay, and then the solve is basically just a matter of taking our puzzle input, which is this. I'm going to grab this and I'm going to put it in inputs, and I'm going to do it as 0, 1A, and paste that in. And then we are going to take this input, which we can see is just a big blob of text, which we are going to want to split up into each of the integers, which we're actually going to have to parse out in Elm. So we can split. So we'll do input. We'll split on new lines for input, and then we will want to convert them. But the thing is, we are going to try to get an int from a string to int. And the problem with this is that it's going to return a maybe because the parse might fail. So what we're going to need to do is, since we know we can trust this import, or this, since we can trust this parse, we're going to say that we want a, I'm going to call it from just to copy Haskell. Say that given a maybe A, we get an A. And the way that we get around this is that if we case this guy, when we have an X, we return an X. And then in the nothing case, we're effectively going to throw an error, which we can do in development with debug to do. And this should compile once I have, oh, this is inaccurate. Here, I'm just going to comment this out for now. Yeah, so that compiles. And then we're going to want to, for each of these strings, actually, we're going to go through each of them, and we're going to filter out, just because I don't know if this split gives us empty strings, we're going to split out, we're going to filter, and we're going to take anything where the string is not equal to empty string. And that's going to bomb again because we're not getting a string back. But this should give us all lines that are just numbers. And then for each of those lines, we are going to want to do toInt. So we'll have a string, and we're going to want to first do string toInt on this. And then we are going to want to do from just. And this should give us a list of ints, which is, it's blowing up, but it's saying that that is in fact what we're getting back. Okay, so now that we've got all these ints, we are going to want to, what do we want to do? We want to map them. Oh, actually, real quick. This just looks kind of redundant to me. What we could do instead is just say that we're basically take the string that we're feeding in and run it through toInt, and then and then after that run that through from just. And if we delete to there, then we get listInt, and that's the equivalent. And it just this is referred to in Haskell's point free style, where we basically take out the point and we just instead define a function that we're passing along, which is what we're doing here anyway. We're just naming the argument. Here we're just defining a function by combining two by composition. So then we can do list map, and we can map each of them to their mass, then list sum them, and then that's an int that gives us, sum gives us an int, and then we're going to want to do string from int, and that should, just like that, it should compile. It compiles, and now if we run and we use our input, we get this number, which, let's see if we got it right. is correct. So that's part one.